Hey everyone, Six String Supplies. Today we're going to do a brief tutorial to explain how guitar pots work, how volume controls and tone controls work as they do. Here we have 2.5 pots, one wired as a volume control, this one here is wired as a tone control, and what we have here is the inside track of a CTS pot along with the wiper. More on that in a bit. Back to basics, we need to know how pots work. Pots are essentially resistors. Resistors, as the name suggests, resist electrical current. A resistor limits or regulates the flow of electrical current in any given circuit. Take a normal resistor, measure the ends with a multimeter, it will give you its resistance reading. Pots, on the other hand, are variable resistors, so rather than being a fixed value resistor, we can vary the resistance impeding on the signal. Now this is great for us guitarists. We use them to alter volume and tone settings, and to be honest, we don't really think too often about how they work. This here is the inside track of a CTS pot. The resistive element is this circular carbon track, as you can see here. I'm just going round. That is essentially the same as this. To measure the overall resistance reading of your pot, you measure it from the outer lugs. That's lugs 1 and 3 on the diagram with a multimeter. So that's the overall resistance. It's the same as doing the same on the carbon film resistor there. The overall resistance is fixed and will never change. But pots enable us to vary this resistance using this. This is the wiper. As we rotate our volume or tone control up and down, we vary the resistance the signal encounters before reaching the output. So as we're rotating, these two lugs here are in contact. They're running along the circular track here on the outside, and then they are connected to these two little dimples here, which run along the inside track here, this metal track, which is the output connected to the middle, lug 2. So if we imagine that well, it's not imagining, but our signal's coming in through the input here. This is where we typically connect our pickup, or it'll be coming from the switch. So that's the signal coming in. And then as we're rotating the wiper up or down, we're changing the resistance. So when the pot is fully open at 10, so that's down this bottom left-hand side, there's no resistance at all. So the signal is jumping straight from the input across the wiper and over to the output. But as we rotate the pot downwards, and I'm trying to reenact that now, you'll see the resistance is gradually increasing as we go around the carbon track. Gradually increase all the way around. Until we get to maximum resistance, which I think in this case for memory was 241. There we go. So we'll just summarize that using the diagram on the screen. So the signal from the pickup or the switch, which is the pickup anyway via the switch, is coming into lug 1 here. That's the signal input. When the pot is fully open at 10, there's no resistance at all, and the signal literally jumps across the wiper and across to the output. But as we dial down that control and we're rotating it downwards, the wiper is moving along the resistance track, the resistive element, the carbon track, and it's increasing in resistance as we go around until we reach maximum resistance at the full end. For a pot to function as a volume control, we must ground lug 3. I'll tend to bend it onto the pot casing that way, or you can use a jumper wire. Here's why. Given what we have just learnt regarding the resistant track and how the wiper works, when the pot is fully open or volume at 10, there is no resistance between the input signal and the output lug. Therefore the signal is at maximum output or maximum volume. As we roll down the volume control, we are increasing the resistance between the input lug and the output lug, but at the same time we are decreasing the resistance between the output lug and lug 3, which is grounded, which means more of the signal is being sent to ground. With the control fully rolled down, there is no resistance at all between the output lug and lug 3, so all of the signal is being sent straight to ground. If you ever have a volume control that isn't fully shutting off properly at 0, it will be because of a grounding fault, and it will be lug 3 not being grounded properly. Tone pots work pretty much in exactly the same way. I appreciate there are several different ways that we can wire a tone pot, but this is the most basic version. I'll cover the other ways in a different video. In the volume pot, the signal is being sent to ground via lug 3. In a tone control, the exact same thing's happening, but it's being sent to ground via this capacitor that's in the way. So you've got the input, you've got the output, and everything that's been sent to ground is going up through the capacitor and then to ground. Our capacitor effectively is a filter. So as the signal's trying to escape from the pot through to ground, it's only allowing the high end to pass through and it's stopping the low end. It's a bit like a gatekeeper. High end's allowed to pass, low end's not. That's what gives us our dark tone on a tone control. In terms of the value of the capacitor, there's quite a few different to choose from guitarist point of view. Typically we deal in microfarads. The general rule of thumb is the lower the value of the capacitor, so for example 0.022, we'll just use that one, or 0.001, more high end is retained. It's more of a subtle roll off, which is why a lot of players, irrespective of if they're using single coils or humbuckers, a lot of players generally, or a lot of pickup winders actually, recommend using 0.022 regardless of the pickups, because it has a nice, a more subtle roll off and retains a bit more high end. And the higher the value of the capacitor, the steeper the roll off and the darker the tone gets essentially. So more and more high end is being sent to ground, it puts you right down into the mid range. Just to summarise that using the diagrams on the screen. So when our tone control is fully open at 10, the signal's coming in through the input lug 1 and it's going straight to the output. There's no resistance, nothing's being sent through the capacitor. So we have our overall tone is at its brightest. And when the tone control is shut off at 0, all of the signal is being sent through the capacitor, but the capacitor is acting as a filter and it's retaining the low end only, and it's sending the high end to ground. So this is where we have our guitar at its darkest or dullest. When it comes to pot values, the most commonly used in most commercial guitars are 250k, 300k, 500k and 1 meg, which is 1000k. In layman's terms, the higher the value of the pot, the brighter your overall tone is going to be. Most commonly, single coil pickups are used with 250k pots and humbuckers are used with 500k. But it's important to note there's no right or wrong answer. Some people mix and match. Myself, I have 500k in my Telecaster. Gibson use 300k for a lot of their Les Paul product lines. Basically, the high resistance pot won't send your high-end frequencies to ground as quickly as a 250k pot does. If you think about it literally or visually by looking at these two tracks, this here is 250k, this is a 500k. They look identical, but the resistance is double. So on the 500k, for example, you won't reach the 250k point until roughly halfway through. That's assuming it's a linear pot, of course, but basically half the signal is not going to be sent to ground as quickly as it would do with a lower value pot. Single coil pickups by design are bright sounding, so they're wired with 250k pots to try and take a bit of the high end off, actually, to tame them a bit, to try and avoid that ice picky tone that some of us, most of us have come across before. If you have a really ice picky Strat sounding pickup, maybe look at the pot value. It could be that it's got a 500k, for example, and then you might want to drop that down to 250. Humbuckers by design, due to the fact that they're humbucking, they're darker sounding, So generally we'll wire them up with 500k pots to allow as much treble as possible to pass through. Let's talk tapers. There are two main types of taper when it comes to pots: linear and logarithmic, also known as audio or log taper. For linear, think of it as a straight line. The respective position on your volume control or tone control is the equivalent position of the wiper with its corresponding resistance. So for example, if you have the pot at 1, you will be at 10% resistance, 2, 20% resistance, 3, 30% resistance, and so on, all the way up to 8, 9, 10, 80%, 90%, and 100%. Log or audio tapers are a bit different, and confusingly, there are several different audio taper variations to choose from. An audio taper pot works in the same way, except most of the action happens at the top of the sweep before turning into a gradual decline. You can see the difference in these curves on the chart on your screen. Linear taper, boom, nice straight line. That's this one here. You can see it's nice and straight all the way up from 0 all the way up to 10. Whereas the audio tapers have more of a steep curve, and you can see here these 1, 2, 3, 4, 5, 6, these 6 different curve lines here. These are all log or audio taper pots. These are all custom options that will be offered by the manufacturer, and you'll see that they all have slightly different gradients from 0 up to 10. And the way they measure these pots is by taking the resistance reading when the percentage rotation is at 50%, so that's right here. So you can see they offer 5%, well, they offer what's known as a 5% taper, 10% taper, 15% taper, 20, 25 and 30. So they are all audio taper pots, and as you can see, there are, well, from this manufacturer, this is the CTS curve graph. There are at least 6 different taper options there, just in the logarithmic variable. One way to think of how an audio taper pot works, just think about when you turn up the volume on your car stereo or on the TV or the kitchen radio, for example. The difference in volume from 10 to 20 is far greater and more noticeable than when you're increasing the volume from 1 to 10. Regardless, all tapers, be it one of the several log tapers available or linear, all achieve the same results. They will all achieve the same resistance, just at different positions on its respective rotational sweep. That's your lot, guys. Thanks very much for watching. We'll see you really soon in the next video.